In today's video, we shall look at a couple of problems that cover crucial concepts such as force, work, power, and momentum. So let's get started. Problem 1. An object of mass 5 kg is free to move along the x-axis on a frictionless track. It starts from rest at x equals to 0 meter when t is 0 seconds. It moves 4 meters under the action of a force given by this expression, where x is in meters. So as you can see, the force is dependent on the x-coordinate. Part A, what velocity does it attain? Part B, find its acceleration at that point. C, what power P is being expended on it at that point. So basically what is happening, this is a motion in one dimension. So that is the origin. This is where the object is starting to move. So it moves under the influence of that force F given by that expression and gets to the point x equals to 4 meters. So for part A, we want to know what velocity does the object attain when it gets to that point. This can be solved using the work kinetic energy theorem. So work equals the change in kinetic energy. The change in kinetic energy means the kinetic energy at x equals to 4 minus the kinetic energy at x equals to 0. We know it is beginning from rest as given there, so that goes to 0. Let's calculate the work done by this force on this object. Now the work is given by that following integral, fx dx. So you have to integrate the force with respect to x, and the limit of integration is from x equals to 0 to x equals to 4. The right hand side, which is the kinetic energy at x equals to 4, is quite simply half times the mass, which is 5 kg, times the speed at that point squared. So this is what we want to determine. So let's do the left hand side. The left hand side meaning you're integrating 2 plus 4x with respect to x from 0 to 4. Now that is quite simply 2x plus 2x squared, and then you have to put in the limits. And this is quite simply the same as that, which is 5 over 2 v4 squared. So let's substitute the limits. The upper limit is 4, the lower limit is 0, so that means that expression would give you 2 times a 4 plus 2 times 4 squared. And the lower limit will simply give you 0. And that is 5 over 2 v4 squared. So the left hand side is 40 and the right hand side is 5 over 2 v4 squared. And we can solve for v4. And when you solve, you get the following answer. v4 is 4 meter per second. Now let's do part B. Find its acceleration at that point. So the point here, x equals to 4. Acceleration is related to the force in a following way. So this is just Newton's second law. If you want to determine the acceleration at x equals to 4, we need to figure out the force at x equals to 4. And that is pretty easy. That is just 2 plus 4 times 4. Just substitute x equals to 4 in that expression. And that equals the mass is 5, a 4. And you can determine the acceleration at that point, which will turn out to be 3.6 meter per second squared. So that's the answer for part B. The acceleration at that point is 3.6 meter per second squared. Part C. What power is being expended on that object at that point? Now power can be written as a product of the force at that point times the speed at that point. So the force at that point is given by 2 plus 4 times 4, again using that equation. The speed at that point is given in part A as 4 meters per second, and together we can compute the power. which turns out to be 72 watts. And that's the answer for part C. Now let's look at the second problem. An object with mass 5 kg is free to move along on the x-axis on a frictionless track, just like before. It again starts from rest at x equals to 0 meter and t equals to 0 seconds. Now it moves 4 seconds under the action of this time-dependent force. T is measured in seconds. Part A, what velocity does it attain at that time? Namely at t equals to 4 seconds. Part B, find its acceleration at that point in time. And Part C, what power P is being expended on it at that time. Note that in this case, because the force is time-dependent, in order to determine the velocity at t equals to 4 seconds, we have to depend on impulse momentum theorem. So what is impulse momentum theorem? Impulse equals the change in linear momentum. However, impulse can be expressed in terms of a force like that as an integration of force, the time-dependent force, with respect to time between 0 to 4 seconds. And the change of momentum is quite simply the mass times the speed at t equals to 4 seconds minus the speed at t equals to 0 seconds. And that is quite simply 0 because we know it starts from rest. So let's do the left-hand side. You want to integrate 2 plus 4t with respect to t between 0 to 4 seconds. And that is just 2t plus 2t squared. And you have to impose the limits, 0 to 4. And that equals to mv4. M is 5 kg, and v at t equals to 4 seconds is what you want to determine. Substituting the limits, you get 2 times 4 plus 2 times 4 squared, and that equals 5 times v at t equals to 4 seconds. So the left-hand side is 40, and the right-hand side is 5 times v4, so that means v4 is 8 meter per second. So the answer for part A, v at t equals to 4 seconds, is 8 meter per second. Now let's look at part B. Find the acceleration at that point in time. Again, from Newton's second law, force at t equals to 4 seconds equals the mass, which is 5 kg, times acceleration at t equals to 4 seconds. Force at t equals to 4 seconds is 2 plus 4 times 4, and that equals to 5 times a4. So a4 equals 3.6 meter per second squared. So that is the answer for part B. Acceleration at t equals to 4 seconds is 3.6 meter per second squared. And finally, part C, what power P is being expended on it at that time? So power at t equals to 4 seconds equals the force at t equals to 4 seconds times the speed at t equals to 4 seconds. So the force at t equals to 4 is 2 times 4 times 4, and v at t equals to 4 is from part A, which is 8 meter per second, and that's going to give you 144 watts. And that solves the problem. As always, thank you for watching.